Today we're going to look at section 2.7 and section 2.8 in geometry. So today what we're going to do is we are going to be applying the transitive property as well as looking at vertical angles. So it says, suppose that angle A is congruent to angle B. So I'm going to mark that in my picture. So angle A, I'm going to mark like this, which means that angle B is also going to get marked like that. It says, and angle B is congruent to angle C. Well, notice that angle B is already marked. So that means I get to mark that the exact same for then angle C. So looking at how we marked up the picture, it says, what can we conclude? So notice that if angle A and B are congruent and B and C are congruent, well, if you look at the markings, it also looks like angle A is congruent to angle C. Notice that they share the same markings now as well. Okay, so what does that mean? Well, that actually deals with these theorems. It says if angles are congruent to the same angle, then they are congruent to each other. You got to replace that with the word segment. So if segments are congruent to the same segment, then they are congruent to each other. Or if angles are congruent to congruent angles, then they are congruent to each other. Once again, I can replace that with the word segment. So if segments are congruent to congruent segments, then they are congruent to each other. These two theorems we are going to be able to refer to as the transitive property. So essentially what this means is that we're looking for a common link. If we can link pieces together, then they are going to be congruent through this transitive property. So let's take a look at this example. It says, given that the segment FG is congruent to the segment KJ. I'm going to mark that in my picture. So FG, I'm going to give it one tick mark, which means that KJ also gets one tick mark. There's two givens. The second given says that the segment GH is congruent to the segment KJ. Well, KJ already has one tick mark, which means that I get to give GH that one tick mark as well because we know that they're congruent. So they're asking for us to come up with a conclusion and to justify. Well, if we're looking at our picture, notice that now it looks like there are three segments with the same tick mark. Notice that it's because we seem to have a common link. We were linking, oops, if I can spell. So we have a common link. It looks like the segment of KJ is linking FG and GH together. So our conclusion is that the segment of FG is congruent to the segment GH. And because there's this common link that is bringing them together, they're getting marked the same because of it, our justification is that this is because of the transitive property. So once again, we don't have to do an if-then sentence. If there's this common link, it's because of the transitive property. So that is enough justification to give me my answer. All right, if we look at this, it says that the ray EB bisects the angle AEC. So I'm going to mark it in my picture. So AEC is being bisected. So that means that these smaller angles of AEB and BEC have to be congruent. Because remember, bisect means to divide into two equal pieces. The other given says that the ray EC bisects the angle BED. So once again, we have an angle being divided into two. We'll notice that angle BEC is already marked. That's congruent to the angle of CED. So I get to mark that the same as well. So it says, explain why the angle of AEB is congruent to the angle of CED. So notice that I have now three smaller angles that are all marked the same. Well, notice that it's because of the transitive property. If you noticed that both of the angles that are being bisected shared a common angle. They shared this angle right here of BEC. So I'm going to explain this transitive property. So both angles, meaning angle AEB and CED, both angles were congruent to angle BEC. So once again, that was our common link. And the moment I have that common link, that's why we got to use that transitive property. All right, so we've got a couple of vocabulary words here. We are dealing with opposite rays. Okay, so to have opposite rays means two rays share a common endpoint and they extend infinitely in opposite directions. Okay, so if I want to sketch a picture explaining this, so once again, two rays share a common endpoint and extend in opposite directions. So here is a picture of one ray. I'm going to call it the ray AB. Okay, so notice that A is the endpoint. It's heading towards the right. So I have to have two rays that share an endpoint. So I have to use this point A again for the endpoint. But if they're going in opposite directions, that means that I need to then have this ray, I'm going to call it the ray AC, going to the left. So to explain this picture, the ray AB and the ray AC are opposite rays. They share the same endpoint of A, and they are going into opposite directions. So essentially, notice that put those two together, we formed a line. Now we have vertical angles. Vertical angles are angles who share a vertex and are directly across from one another. That's because the sides are formed by opposite rays. So if I was to sketch a picture, here is one set of opposite rays. Okay, because VW, that ray, and VZ, that ray, they share the same endpoint of V. They go in opposite directions. And then here are two more sets of opposite rays because they share the endpoint of V, but notice that the ray VX and the ray VY are going in opposite directions. So let's say here is angle 1 and here is angle 2. Notice that both angle 1 and angle 2 share the same vertex of V, and they are directly across from one another. So both of the sets of sides are opposite rays that are forming them. So I would say that angle 1 and angle 2 are vertical angles. Okay, so why did we need to know about vertical angles? Well, it's important to know that vertical angles are congruent. So this is a theorem that is going to be put to use quite a bit. We can use it when we are looking at pictures and now kind of assuming things, okay? As long as they're vertical angles, we know that they are congruent. Or we can then take this information and apply it to some algebra problems. Okay, so let's look at this example. It says, based off of the diagram, what can we assume and why? So there are three different angles in this picture. There's angle 1, angle 2, and angle 3. Nothing is marked in my picture. And so remember, the only types of angles that you can assume are straight angles. However, hopefully we notice that in this picture, angle 1 and angle 2 are sharing the same vertex and they are directly across from one another. Okay, so because they are across from one another and they share a vertex, I can say that angle 1 is congruent to angle 2. And this is because vertical angles are congruent. Okay, so that's my justification as to why I'm able to say that those two are congruent, even though I don't have anything marked as such. Okay, as long as they share the same endpoint, are directly across from each other. Notice that the sides that made up those angles are opposite rays, but vertical angles are congruent. All right, look at this given information. We're told that the measure of angle 4 is represented as 2x plus 5. Angle 5 is represented as x plus 30. We want to find the measure of angle 4. Notice that these two angles share this vertex. They are directly across from one another. Angle 4 and angle 5 are vertical angles. And so vertical angles are congruent. I get to set those two expressions equal to each other, even though I don't have the markings showing that they're congruent. But based off of our theorem, vertical angles are congruent. So I'm going to subtract the x. I'm going to subtract the 5, and I get x to be 25. Once again, that's not my final answer. I need to find the measure of angle 4. So I'm going to substitute that back in. So 2 times 25 plus 5. Well, 2 times 25 is 50, and when I add 5, we'll have a 55-degree angle. All right, in this next picture, we are given that angle 1 is a measure of 72 degrees. They're asking for us to find the measure of all the angles. So I need to find the measure of angle 2, the measure of angle 3, and the measure of angle 4. Well, notice that angle 1 and angle 3 share the same vertex. Actually, all of these angles share the same vertex. But angle 1 and angle 3 not only share the same vertex, but they are directly across from each other. And so remember, that means that they are vertical angles, and vertical angles are congruent. So that's why angle 3 is a 72-degree angle. Now we just have to figure out what angle 2 and angle 4 are. Notice that angle 2 and angle 4, those are vertical angles as well. So the moment I can find one of those angles, I'm able then to say that that's the same measure as the other one. So this now takes us back to our understanding of what you can assume about angles in a diagram. And the only thing that you can assume is that you have straight angles. So I just highlighted a straight angle. Notice that that straight angle is made up of angle 1 and angle 2. So that means angle 1 and angle 2 together are forming 180 degrees. So in other words, they're supplementary angles. And so to find the measure of angle 2, I am going to take 180 and subtract 72 from it. So when I do that, 180 minus 72 gives me the measure for angle 2 to be 108 degrees. And like I said, angle 2 and angle 4 are vertical angles, and vertical angles are congruent. So that means that angle 4 is also 108. All right, in this problem, we're asked to find the measure of the angle ABC. So I'm going to highlight that angle, ABC. So that means that I want to figure out x and y, so then I can plug it into that angle and know what the measure is. When we're giving all of these different expressions, we need to think about what you can assume from a diagram so we can set up an equation. Notice that in this picture, we actually have several different things that we can assume. One of them is that we have some straight angles. So if I highlight with a different color, let me use green this time, notice that here I have a straight angle, and it's made up of those two expressions at the top. So I can say that y plus 30 plus 6x plus 10 has to equal 180 because together those two are forming a straight angle. Okay, something else that we now know is that vertical angles are in this picture, and we have two vertical angles that happen to have expressions. And remember, vertical angles are congruent. So this expression and this expression are formed by the vertical angles. So I can set y plus 30. I'm sorry, up here I lost the 5. So I have to say y plus 30 plus 5. No. I'm sorry. I'm now looking at a whole bunch of different things. I'm sorry. So that was right. Okay. So y plus 30 plus 6x plus 10 equals 180. And then now down here, y plus 7x plus 5 is going to equal 6x plus 10. Because once again, those are vertical angles, and vertical angles are congruent. So essentially what we've created is a system. Because there's both x's and y's, I needed those two equations. So I'm going to simplify. On the top, notice that I'm going to move my two numbers over to the other side to then have all the numbers together. So that means I have to subtract 30 as well as subtract 10. So I'll still have the x and the y. I'm going to put the x first. So I'll have 6x plus y equals 180 minus 30 is 150. When I subtract 10, that's going to give us 140. If I look at the bottom equation, I am going to move the 5 over to the other side so I can have the numbers together. And then I got to get the x's together. So I'm going to subtract that 6x over to the left. So 7x minus 6x is going to give us x. We still have plus y, and now that is going to equal 5. Okay, everything's set up here for us to do elimination. Technically, if you want, you could get one of the variables in the bottom equation by itself, and you could do substitution. For me, I'm going to do elimination, and so in order to do that, I have to have opposites. Right now, the y's have the same number in front. I just need one to be a negative. So I'm going to multiply the bottom equation by -1. So that doesn't change the top equation. But in the bottom equation, now I'm going to have a negative x minus y equals -5. So now I can add these two things up. That's going to give us 5x. The y's cancel out. That gives us 135. And so when I divide 135 divided by 5, I can get my value for x. And so I get x to be 27. Okay, because once again, I need to know what angle ABC is. That's this expression here. We need to find the y, so then we can plug it in. So if I go back to, say, this original equation, do it in yellow, before I had multiplied, let's plug the 27 back into that x. So we're going to have 27 plus y equals 5. So I'll subtract 27. And that gives us y to be -22. And so now that I have that information, I'm going to be able to plug that in to find the measure of angle ABC. So we'll have -22 plus 7 times 27 plus 5. All right, so I'm going to take -22 minus 5 to give us -17. We'll have 7 times 27, which gives us 189. And so then when I combine those two numbers, we find out that we've got a 172-degree angle. Okay, so it took us understanding how we can assume different things. We've got straight angle and we've got vertical angles that allowed us to set up a system, and then I solved by elimination. So that's us applying the transitive property as well as recognizing vertical